Okay. Hello, everyone. Welcome to another edition of HEIR Monthly Meeting. So I'll go through the last month's changes and then discuss. So we had 60 PRs merged since last month in roughly chronological order. We checked in an AES transciphering demo, and I think that's all through CGGI. And then I think there's some additional work in progress on like improving that. There was a CRT support added to the Mod Earth dialect that supports doing decomposition and recomposition in the CRT basis using the RNS types. There was a new contributor who added a layout conversion cost analysis that sort of simulates the cost of doing a layout conversion in order to determine like whether it's appropriate to hoist a layout. The LWE type migration was finished, so now we only have one LWE set of LWE types. So thank you, Asra. So we had a bunch of minor improvements in preparation for and in response to the HEIR hackathon. So we had a one-day workshop in the Portland office that I called FHE at PDX. We had a half day of talks and a half day hackathon. And so I think we'll have more to discuss about that during the meeting, but it was a lot of fun. Now the Python frontend supports passing in like a raw MLIR string as input if there's something you want to do that isn't supported by the actual like thing that parses the Python bytecode. Okay, so now our documentation has auto-generated examples from lit tests. So there's like a special command that you can put inside the markdown, and then when it generates the tests, it will run HEIR opt. It will like find the file that is referenced in that command, run HEIR opt, and then show the before and after along with the command that was run. So that's pretty cool. I had a chance to update like 3 or 4 different passes with examples, but there's a lot more that could be added. So if you want some easy contribution, then you can go extract some of the examples from the documentation into proper tests and then replace it with the little help string. I also thought this might be like a stretch problem for a large language model to figure out, but we'll see. There's now a lowering from arith negation to CKKS negate, and combined with that, there have been some lowerings for arith comparisons down to CKKS comparison, or arithmetized comparison operations. So also in preparation for the HEIR hackathon, we reorganized some developer docs, so now there's different information about IDEs and different integrations. Things are a little bit cleaner now on the website. So we have OpenMP enabled by default now. There was some issues with the front end that got fixed, and now OpenMP is enabled by default, but it still doesn't work on macOS. So I found out that OpenMP is just like not supported by Apple, period, for their new silicon chips. So you just can't use OpenMP on macOS. I don't know if that's like 100% true, but as a result, we are. I can't get the CI, the macOS CI, to quite work with this, but I have a PR that's trying to disable it just for macOS and then enable it for everyone else by default, so that people don't have to like on flags. Okay, so as part of the hackathon, we started lowering CKKS relinearize op. What's his name? Eric Crockett from I forget where he's at now. Okay. Anyway, Eric Crockett, who was at the hackathon. Yes, exactly. So he's interested in implementing some of CKKS in the compiler so that we can target their hardware a little bit easier instead of going through a library. And he's an expert on like relinearization. So we start with relinearize, and we got the first step of that done, which actually involved quite a few changes to different dialects. But okay, that's ongoing. Humran, I believe, added a CKKS range analysis, or just like a generic worst case range analysis, so that we could have some worst case parameter selection. Still no progress on the average case parameter selection for like machine learning models, but yeah, I might find some contributors internal to Google who would help with that. I also did a little bit of like maintenance stuff. I upgraded the C++ standard C++ 20. That's what Google uses internally, and so all of our code just magically works with that. And that means that we can do like ranges and like easier APIs that have been added to C++ 20 now. As a result, Clang 15 and 16 don't support C++ 20, so I officially dropped it from our test matrix and added Clang 20. There's been a lot of work on the new layout system in terms of a lot of work in the background, and then the one PR that's been merged is changing the actual or adding an attribute that corresponds to like the new layout in terms of like integer relation. So okay, we'll talk about that a little bit more. There's a new builder style from upstream MLIR. So what happened was somebody in the MLIR forum was like, I don't like the way that we do builder.create and then it forwards all of the args to like the templated operation because IDEs can't recognize or autocomplete anything really well. So they added a new builder style upstream. They're going to deprecate the old builder style, but now the new builder style is operation name : create, and you pass in the rewriter as the first arg. But now it has like full autocomplete support, so it should be much easier. And then I have a PR that just migrated our entire code base to use the new style so that nobody tries to use the old style by mistake or by copy paste. Okay, so there's been some updates to CGI pipeline for doing loops. And then we're working on a generalized baby step, giant step lowering. And the first step of this was having a high level op that represents rotate and reduce, sort of like generic structured form that you can lower to baby step, giant step. And so I think there's going to be more work on that, but we can talk about that. Okay, so that was PRs that got merged. A lot of the other stuff that got merged that's not in this list was like automatic migrations from Google internal things. So that inflated the number a bit. Okay, in progress PRs. So as part of the layout changes, I determined that that we basically need ISL, the integer set library, for doing code generation for like generating the code that implements the packing. And so I have enough prototypes to convince everybody that this will actually work. And then I did the work of making the ISL code base compatible with Bazel, which was like a non-trivial amount of work. But now it should be easy for us to add dependency on it and then implement, use the API like pretty straightforwardly. The surprising thing is that I found lots of people who are building projects based on MLIR that end up depending on ISL for like polyhedral analysis stuff, because the upstream MLIR Pressburger library is just doesn't have enough features, and what they have implemented is just not good enough yet. And then I have a first pass layout code gen that was like my prototype before I decided to use ISL that will be replaced by ISL. So I think that PR might not even get merged. Okay, so we had Mutu added a Docker file for HEIR development. So if you've been having trouble with the build, then if you have Docker and you like to use Docker, then you can just use the Docker file and do your development in there. I have a PR to disable OpenMP on macOS. This PR works for people, but it doesn't work in the CI, and I don't know why, and I can't figure out why. So I'm occasionally picking at that to try and experiment with it. We have a PR that will remove memrefs from the CGI pipeline so that basically we don't do bufferization so early anymore. We have a new SBox implementation. I believe this is from the KU Leuven folks, the caustic folks, on like doing AES transciphering with like arithmetic operations instead of lookup tables, which Booleanize nicer, more or better for FHE. We have a draft of a scheme selection pass, which I have not looked at yet, but I think it just does high level, should I use CKKS or should I use CGGI for this pipeline? And then I think there are PRs that haven't been pushed yet that we're working on to do the actual baby step, giant step lowering. and to do migrate the layout propagation to use the new layout attributes. Okay, notable new issues. There were a bunch of new papers that were added to the list of papers to investigate. Yeah, okay, I won't go through them all, but this one here is Edward Chen's, and I think, I don't know if, okay, yeah, anyway, I'm working with Edward Chen on some integrations here. Okay, what is this? Okay, yeah, so this is the new layout changes, scheme selection pass. Yeah, I don't know how valuable it is to go through all of these in detail. Yeah, okay. I mean, you guys can read through them if you're interested. I don't think there's anything particularly notable to discuss in these issues. Okay, so on to opening the floor for topics. I don't know if people are worried about adding new dependencies to the project. ISL, okay, we'll say this. The Bazel build for ISL takes about 5 seconds on my machine. So it's not a heavy dependency in terms of build time. It is a weirdly designed C program. Like it's not even C++, it's just C. And the Bazel build is not trivial. And I had to check in some like autoconf generated files. So that may result in weird builds happening differently on different machines. But it's like, reach out to me if you have issues building it once that gets merged, and I'll fix it. But otherwise, like I don't think there's going to be much of a maintenance burden for actually updating the code itself, because the code is pretty mature and stable at this point. Yeah, Alex.
I assume since it's a small C program, also not an issue for the Python packaging?
It's compiled along with it, so it's compiled from source, so it's not like a distribution dependency.
Not like okay.
Yeah, not like Yosis exactly, or not like not like Yosis and not like OpenFHE. So it's just part of HEIR opt compiled into it. Okay, I guess the other big topic is oh, down here I have an example of what the auto-generated documentation looks like. I put that screenshot in there like a month ago, and then I opened this doc yesterday, and I was like, who put this screenshot in here? It was me. But yeah, so this shows what like I have these files, I'm calling them doc test. And so that is like my like base name for tests that end up in documentation. But then it shows it all nicely. Okay, yeah, so one of the bigger decisions that we made in the last month was that we're gonna start implementing the core crypto primitives in HEIR sooner as opposed to later. So most of the people I've been talking to doing hardware, don't like tracing library APIs and maintaining a mirror of library APIs. And I didn't realize that this was such a big problem until I think it was, I mean, I know Alex has always complained about it, but it seemed like you guys were still going to do it anyway. But then like, I think I had lunch with Dave Archer and they were like, we hate doing this. Can we please not do it? And then I think Eric Crockett was the last one who was like, oh yeah, like we don't even want to start attempting this over here. So I think that this, all the hardware people are saying this is going to be the easiest path forward. And so, yeah, I think we're going to start with just CKKS to see if we can implement, that's probably the hardest one, I think. And that's also the one that I understand the least. So people who love CKKS and want to help with that, I would really appreciate any help in lowering the rest of the CKKS ops. And then the first step would be like just getting a lowering that can go end to end to LLVM. And running CKKS through LLVM would be really cool to see, especially any performance differences that we have from being able to, this is the Heian MLIR selling point, is that they just lower to LLVM and they get a bunch of optimizations for free. Okay, so yeah, help wanted for that. I will be spending most of my time over the next month building, finishing out the packing stuff. So I won't have too much time to like do deep dives on other parts of the code base. So yeah. All right, opening the floor for discussion.
I mean, I have like 1.5 more weeks in Berkeley, but when I'm back, I think lowering core crypto primitives is going to be my main focus for the next few months. Not least because I did just have to write a new like tracing implementation for OpenFHE, and apparently my complaints aren't valid, but Dave Archer's are. But yeah, it sucks. It really is quite annoying to trace OpenFHE, and I think as soon as we want to, I mean, I'm happy to. I think my code is open source. I'm happy to share that with other people who have, more clutchy, maybe not up-to-date tracing versions of OpenFHE, which I think is all of the companies at the moment. But I, like, despite just having created this tracing framework, I really don't want to use it. Like, I want to get rid of it as quickly as possible. Yeah, I guess we need to sync up with Eric again, continue that work. There's also some people at Stanford that I wanted to reach out to and see what sort of the recommendation is for the variety of like recent papers on how to do a key switch most efficiently, and to try and understand a bit more. So I think that would also be something if you're, if you're more interested in the crypto side, or if you know somebody who's really into the, crypto algorithm side of FHE, but maybe not so much into compilers. We would love to, I think, sit down, maybe have like a special topic meeting at some point about, hey, what's the actual state of the art, right? Because there's about a dozen different papers that came out in the last year or two that all claim that they are the magical solution to how to do, let's say, bootstrapping. And they are usually in contradiction from each other, right? Like some of them clearly compose, but definitely there are some trade-offs between like, memory heavy versus compute heavy, making certain assumptions on the operations that are available natively on the hardware, all these kind of things. And it's, at least for somebody who's sort of from outside the area, it's very intransparent, and it's not even like clear which papers are even worth reading, and which, definitely not clear which papers are worth implementing, right? So the first step here will just be to have an implementation, right? But I think then, especially if you want to sort of offer that HEIR and MLIR level speed, we're going to have to figure out the algorithm side in addition to whatever LLVM lower level magic.
Yeah, I think also I wanted to, I saw a bunch of discussion on the scheme selection pass, but didn't have a chance to look through it. So I think, Mark, were you involved in that? Or maybe you can give an overview of what you guys do?
Yeah, I mean, the scheme selection pass is, it's kind of intended as a starting point for the for scheme switching also, and as a kind of a guidance for inexperienced users. So if you want to use HEIR but don't know the ins and outs of different schemes, then it's then this would be a way to help you decide on a scheme. And this has to be done kind of early on, because you need the algorithm, and you need to check the algorithm which scheme would be best suited for it. And if you then think on how to go further to scheme switching, it's basically splitting up the code into different chunks, and then doing the same thing as you did before for scheme selection. The hard part here is that there are no real cost models that are. There is a cost. I saw a cost model for CKKS, but it's only for CKKS, and there's nothing that is comparable for overall schemes. So we have to look how we're going to solve this to create some cost model that is general for all schemes.
So have you looked into what the Chinese HEIR compiler was doing? So they're the only compiler out there that does scheme switching already. And so they presumably, I mean, they said they've done partitioning and then they have some cost model, but I haven't looked at the details.
I read some part of your, I don't know whether this is the same paper. You read a synopsis of some paper, or you wrote a synopsis of some paper where they also claimed that they did some sort of scheme switching, but it was kind of hard coded. And honestly, I think that's the same thing there.
Okay.
There's no real discussion about what schemes there how they're really going to partition the code in different ways, and how they're going to switch schemes. It's also they decided these parts are done best in GFAG, and the others are best done in CKS. So
Okay.
Yeah,
Cool.
I
And so
think
what? Oh, go ahead, Alex.
one really simple cost model that we have right now is the cost is infinite if it's not implemented, right? So what, like, simple cost model, what is supported, right? And I think this makes me think that first, like, in addition to doing more research, which I guess this is like academic level research on what the cost model should be, there's also an interesting question here for us from the infrastructure side to see how can we support work on this? Because currently the compiler has no mechanism, MLI in general has no mechanism to bubble up information about what's supported. And so I think this is something we can think about, which is like, how can we expose what is supported to things that want to do cost models, right? Because otherwise I think the maintenance burden becomes a bit annoying for, every time we add support for something here and there, we probably don't want to have to manually go and like write a bunch of updates. But at the very least, we want to know which cost models need to be updated, right? Something semi-automated, maybe. Which maybe that already exists upstream. I don't know, but it doesn't seem like something I've seen before in MLIL.
I don't think so.
I guess the first interesting question would probably be the comparisons, actually, now that we support them for CKKS. And, support here being a very strong word for a very minimal implementation. But yeah, I think like if you can maybe start thinking about like what a minimal like decision logic for that would be, right? If you assume a very simple program and it just has a bunch of, arithmetic that's supported both in the CGGI branch and in the arithmetic branch, and then it has like one comparison, right? Like, or like two comparisons, right? Like, where's the like trade-off point and how do we calculate that? So I think because we have the support for it, right, we can actually write end-to-end tests. And also I think it's interesting enough to like hopefully push us in the direction that actually gives like more general results.
Yeah, what was there was some application that someone did for some iDash competition where the program ended up being big matrix vector multiplication plus small decision tree, right? And like they said, okay, the best thing to do here is CKKS for the matvecmul, scheme switch, CGGI for the small decision tree. And I feel like that would be like a really good driving test to be like, okay, can your thing find, I mean, it's like probably like 5 ops, right? But like find the partitioning point at which that makes the most sense, and have that be consistent with the cost model.
Yeah. I mean, the most simple cost model that is currently in this prototype is simply counting different types of operations, and so the comparisons are counted as one type. And I have some nonlinear operations I count, but then you start which operation is worse than the other. So is it the comparison, or is it something?
So what does it do? Does it just like how does it once it has the counts, how does it decide?
The decision is the decision I have a problem with, because it's what I'm currently doing is I annotate the functions with the numbers, and then it would just be a seminar checking which are the max numbers, and deciding hard coded on that if the comparisons are if there are enough comparisons, then I'm going to use TFHE and so on. But the problem here is that I can't annotate the module, or I cannot. So somehow the data flow doesn't allow me in the visit operation to go over the functions.
That sounds like something we can fix. Yeah, why not? Maybe if you have your PR and you can like point me, like ping me in your PR to like where this is happening, then I can try and figure it out offline.
Okay.
But yeah, I guess the other thing, this like maybe the right approach for starting is just to like profile each of these things in isolation, like profile what happens when you lower an arithmetic statement to CGI and to whatever to CKKS, and then just run it.
Yeah, after reading the capo and the RE BDSM, they basically did the same thing. They timed different CKKS operations for different levels, and it's a little bit exhaustive because you're going to have to do this for different levels, and different parameters sets would have to do that, but maybe one standard set has different.
I feel like at the end you would just like kind of get a blended cost. Like like you could blend it like smartly by saying like, oh, this is like a weight on how often you're running at this level or something, and like then like average across a decent set of parameters or something like that to get a blended cost. But then I also feel like in the longer term we could use like profile guided optimization. So for the specific program you have in mind, we could have something where when you compile it and then it ends up choosing one particular partition, you can give the runtime information to like a file, and then the next time you compile it, you can load that information, and it can be like, oh, well, like if I try, you know, if there's some flexibility in the parameters, I can try different versions of those parameters, get a bunch of different profiles, and then use that to know which one is the right thing to do for this particular program and the particular backend target. Like this is something Google does a lot. Google will basically say, okay, I'm good. Like I have like this like critical video codec thing that's like running on a bunch of different GPUs or whatever. Like, okay, I'm going to just like, you know, run 1% of them with different randomly chosen parameters and get a profile of how the performance changes and all these different things. And then once I find something that's like significantly better, I will use that one going forward for everything. So this is like I feel like this would have a lot of benefits in FHE, just because the differences are pretty drastic when you hit on like the right thing.
I guess this is like useful for this, but also just, you know, core to the benchmarking mission of HEIR is we should probably have support for profiling and benchmarking, like as just, you know, a thing that you toggle in the compiler, right? Because right now we give you, you know, we give you code that you can then, you know, slap your own timing calls around. But I think having profiling for at least OpenFHE and TFHERS would probably be a useful thing. And then if we're doing it, you know, in some standardized HEIR way, that means we can also define like, you know, some output format or something that we can then later on pass. I think another sort of to do, not for scheme selection, but for scheme switching later on that we want anyway is the OpenFHE binary FHE interface, right? I vaguely remember somebody was working on that, right?
It's done. It just hasn't been upstreamed. So there's a published paper that uses it.
There's also, I mean, his fork is now public for it. But I agree. That's kind of what I was waiting to say. Like, it'd be nice if we could compare those costs around the same backend. So it's not like, yeah, let me link it in.
Yeah, I'm curious how we would do profiling with like different library backends. I mean, like, I guess, like, right? Like, I don't know.
Yeah, it's the same thing for CGGI as well. If you just look at the current accelerators that are on the market, like all of them have a different paradigm to talk to them and to execute operations. So that alone is already that need to be taken into account as well.
Yeah.
Yeah, it seems like a hard problem, but I feel like we could have something useful for our purposes that is just like inserting something that like if we're assuming we're just running on CPU, right? And we're just doing benchmarking of, yeah, I don't know. Like the stupidest thing to start with is you just like insert a bunch of timing calls around each operation, right? And then like you get latency in a single threaded situation. But I don't think that's like really scalable long term. I think like the thing that we would need long term is some instrumentation at a low level. And I've never done instrumentation work before. So I might need some help from some real compiler developers.
Yeah, I mean, I think one of the nice things is that FHE is slow enough that you don't have to worry about many of the things that real world implementation has to worry about, right? Like,
That's true.
if you spend a couple thousand cycles building up your instrumentation framework, that's just a blip in the FHE world, right? So,
right, the overhead's not important, but like the diversity of different platforms, I think is and library backends and stuff is tricky.
I mean, I was specifically thinking for the things where we support code generation, right? So DFHE, RS, Latigo, and OpenFHE, it makes sense for us to also support, some kind of at least basic profiling benchmarking. That might just be sort of using Hongren's debug system, maybe, right? Like the debug flag or some other
right, and just inserting timing stuff, right, around in that context.
Like, it doesn't have to be very elegant, right? It just needs to be some kind of information for the system to use. Like that's probably not going to work for like, really finely detailed profiling stuff, but it should work for, basic like selection of schemes and stuff. And I guess in sort of like the format, I guess what we really want is we have some kind of exit IR, right? The last step before we go to whatever backend specific. So I guess like we have the actual exit IR, which is something OpenFHE specific. But I guess for a lot of these like more generic analyses, what we probably want is like to raise that to return that information to the actual like scheme level dialect IR that we had, right? And so having like a timing annotated version of, let's say, the CKKS dialect version of the program before it sort of goes to the OpenFHE backend pipeline, I think that will be really helpful. And so, there's like some work in actually getting those numbers and then some work in like getting those numbers back into like attributes on the IR.
Yeah, I mean, I'm not sure if we would need like per attribute timing information, like per op timing information necessarily.
Also
like
module.
I mean, I don't see it as necessarily right. I mean, like you could sideload it as a file, like. If like for like the basic thing we're talking about, just having like a blended cost for each op.
I just think conceptually that's sort of like the level that we're looking at, right? Whether we actually put it into the IR as an attribute or whether it's sideloaded, I think like, like for this to make sense, we don't want it at the OpenFHE exit like IR level. We want it at the like CKKS level, right? So there needs to be some slight amount of phrasing. But that's.
I mean, I feel like we could even just have like an op, right? Like.
Oh yeah.
Have a dialog that is like start time, stop time, and then like we can emit that at a high level and then just have code gen for it at each exit point.
I like that.
Like
what are the ops that Hongren added for those were function calls, right? Okay, those are
function calls. And I also wonder if like we could have something where we do like timing dot start and then like linalg dot matvec timing dot end, right? We insert this at the very beginning, and then when we lower this, or okay, I hesitate to do this, but timing time with a region, and then when we lower this, we can have a timing statement around the linalg matvec. But then also, when this gets lowered, it could get lowered to timing dot time around the individual steps of the like lowered kernel, so that like we could, and maybe we could call this like keep the op name here to be like, okay, this whole thing is a matvec, and we're going to time it as a unit. But then this is just the like rotate. Tensor x dot rotate, and we're going to time this as a unit along with other stuff that happens later, right? Like add I.
I think,
right? And then we could have like a hierarchy of timings that correspond to the. I don't know. That seems cool. I don't know how hard it would be to do this with regions, but.
It seems very MLIR, and I think it also like really lovely. It's going to stress part of our pipeline, which is like dealing with code in nested regions that we don't necessarily do amazingly well, like generically. So I think like this will probably break the pipeline in so many places, and I think that's like a feature, right?
Yeah, I
Because
think
it will
a
force
lot of
us.
our code like checks, you know, we won't forward things through, you know, different regions and stuff like that. So, and I think we had that secret separator op to at some point to like separate separate parts of the module. And for that one, because we decided like the region thing would be too complicated, for that one we just like slapped on a like a false mem effect and made it like a
Oh yeah.
right.
I mean yeah, that's the other thing is that we can, but like I was thinking that like if we did like timing.time or timing.start, timing.end, and then like lineage.matvec, and then like we lowered this to
In
like
some degree, timing.start, there is like a effect going on about a timing start, right?
right, but like I'm saying that like if you were to like you'd have to match on this in order to know that this thing corresponds to the matvec. And
Yeah, I
then
see.
then basically you're manually doing the nesting, because then okay,
Yeah.
what if there's like a matvec in here as well, like something that lowers to 2 matvecs or something, then
Yep.
like okay, you have a matvec and then another timing start matvec and then 2 end matvecs, and you're balancing it kind of like manually. The regions does that for you, I feel.
By the way, I think we could solve that with symbols, right? Like the string that you have here as like the identifier could just be like the human like helper, but we could just use like you know, some unique ID symbols. But no, I think like the region thing is still more interesting, and I think like the fact that this is hard for our pipeline to work with is like a pro, not a con for this approach, right? If we
I
really
don't think
need
it'd
this
be that hard.
No, that's my point. Like, but like, I think like
Yeah.
it will force us to fix a variety of like hard-coded scenarios where we just don't deal with regions properly, right? I mean, I guess also we don't need this very urgently, right? So I think the like side
Yeah.
effect version probably we can get that much quicker, but I think the region version is what we want. Cool. Hey, productive brainstorming session. Thanks, Jeremy. Yeah. So I think one of the things I would love to see is maybe if you can also what is it? That's from Regev, right?
Yes.
The Boolean thing. I think yeah, if we can just reach out, maybe ask him if he's interested in upstreaming it. I had a quick
Oh,
look
we've
and
done that many times, and I'm in regular contact with him, and he was always like, "Oh, I don't have time to clean it up. Like, I want to do this, but I don't have time for it right now." So I think I was just gonna bite the bullet at some point and upstream it, but yeah, I think I'm gonna really have to finish my packing code before. I mean, I don't think it's gonna be hard to upstream it, is a thing, because we've done basically all of the work for OpenFHE already. Like, it's just a matter of getting the code gen and the like dialect. Like, it seems like it'd be really straightforward. But like this packing stuff has been looming over me for the last 6 months, and I really need to finish it. So, and the end is in sight.
Yeah, I had a quick look, and I think the main problem is that he's like 1,000-something hundred commits behind main currently. So I think that the main effort will be sort of like, you know, taking his code and re-implementing it on top of like modern.
Right. Right.
Cool. Yeah.
Also, I'm wondering, do we really want BinFHE in there? Because it's still the Boolean API.
I don't think it's going to be good, right? Like, it's not going to be the best CGI implementation out there. But I think we would need it if we're going to do scheme switching, because OpenFHE is the only library that supports CGI and CKKS in the same code base.
Also, like the real power of CGI is not in the Boolean parameter sets; it's in the shortened API.
I agree.
So I think
you want to implement that in LLVM?
So, yeah, I mean,
the thing is, if you can persuade Ingrid, I think we can.
I'll try. I mean,
I've implemented CGI. That's the one that I could lower to LLVM if I had the time, right? So I'm not like too worried about that. I mean, I guess there's some advanced stuff in there that I haven't seen yet.
We have implementations laying around at Cossack as well, but that I don't think that's the problem. I just don't know if it's worth the work to port the Boolean scheme. I
think this would be 1 day of work. I think, like, I don't think it would be less work definitely than implementing CGI. And I think that there's probably some benefit to having it just for comparison purposes in the future paper.
That's also
like I'm
thing.
not opposed to having it, and we already ship it and we already build it, and it's I don't think it's a big deal. But yeah, it's definitely not going to be like the best, because I think they're just not developing it anymore. Like they haven't developed it
No.
since
Yeah, also, I think
programmable
they're-
bootstrapping was invented.
Yeah, I also think they're just now afraid to implement it further.
Yeah, patent reasons. Yeah,
Yeah.
understandable.
I also think that, you know, the scheme switching stuff really only makes sense if we have our own implementations, right? Because I think, for example, like you don't want to scheme switch between TF-HEIR and OpenFHE. Like technically, maybe you could write like a little translation thing between the ciphertext formats, but like why would you, right? Like why?
You have like completely different noise models for start. That's like already the problem.
Yeah, like
So,
you would have to do so much work doing
if that would be
something would be
secure.
more effort than re-implementing the schemes, right? But I think having OpenFHE, I guess also this allows us to claim that we completely support OpenFHE, which I think is like a nice
Yeah,
thing to
that's
say.
also a thing.
And there are a bunch of like existing programs written against the scheme switching, like OpenFHE API, right? And I think my main reason to do this is because I remember we had this, like I didn't realize it was like done, but I knew somebody had worked on it, and I think it's the fastest way to get into like really easy scheme selection and scheme switching like playground. I don't think we'll ever want to actually lower any workloads to this, right? But I think it's like, yeah, like having it so that we can have working, running, you know, like scheme switching, like, and then we can play, right? Because there should be programs where even the like bin FHE implementation is better than doing a approximation, right?
Yeah, I think also like the fact that we'll have a quote unquote bad CGGI implementation will force us to design the scheme switching in a way that doesn't depend on the details of the implementation at a low level, right? Like, because we're going to have like, say we have like a bad CGGI implementation and a good CGGI implementation, we will want the scheme switching thing to be able to identify that like, okay, this is the place to partition it if you're using the bad implementation versus this is the place to partition it if you're using the good one. And I think that's like a really useful forcing function.
I think in some way,
if you know, like if we design this thing for bin FHE and we know we're not going to use it, then like we really want to avoid depending on any of the particular ways that it happens to do stuff.
Does anyone know if scheme switching will be supported in Latigo? Or if that's on their target?
I doubt it. I don't think it's in the immediate roadmap. I did talk to what's his name about this. Yeah, I talked to Jean-Philippe about this briefly, and I don't remember. It was kind of non-committal, his response, if I recall.
Given how more permissive the API is, once we have a like 2 LLVM pipeline, that implies that we also have a 2 polynomial version, right?
Yeah.
We can probably just emit like Latigo, like we could probably like emit the same like scheme switching instructions that we do, right, for like a completely LLVM instruction, just at the like Latigo polynomial level. So I think like that would not be feasible, I think, with OpenFHE, like the like DCRT poly level is pretty trusty. But with Latigo, I think the polynomial level is like nice enough, and you can access that from like a scheme level ciphertext quite nicely. So we could, I guess, sort of like.
But what would be the point if we have it to LLVM? What would be the point of emitting to Latigo?
We can benchmark like how much better our thing is, right? Even for scheme switch programs.
Sure.
Yeah, and I also I feel like that it might be better performant than the all the way to LLVM lowering.
Like that's like I mean,
well, Go is compiled through LLVM. So.
Oh no, well I guess like part of it is I think like the the NTT app like that we have is just like a simple naive butterfly, and I don't know, maybe there's like something better in Latigo, but then again Latigo is also single threaded, and I don't know if I mean there's going to be more work that we could probably do.
Yeah, I guess it's like not the highest priority thing by far in this like entire like scheme switching range, but I think it is like an interesting showcase. I think it might make like for a nice like paragraph or two in the paper to showcase sort of the power of like partial lowerings and stuff.
Actually, like I mean, as a starting point, we should just benchmark the NTT that we have. I think there's already a polynomial lowering all the way to LLVM that has the timing information. There's like a polynomial runner, like we could just run that and also just test out the same sized NTT in Latigo and see what's better.
Yeah, I mean, I have strong opinions on like whether or not benchmarking entities is useful investment in time, but I think For like FHE applications, no, but like for hardware, no. But for a compiler, I think actually this might be a relevant micro benchmark.
Yeah, I mean, it's also useful. I mean, if we're going to emit at the level of polynomial NTTs, then it's useful to know.
Yeah, I think it also gives us like a target. I think like maybe we can even do the same for OpenFHE. Like the API is a bit crusty, but it does exist, right?
But that has less use, like to your point of
yeah. But I think again, like that's probably important for any paper we want to write about the LLVM path, right? Like I think beating Latigo is nice, but again, like I think OpenFHE is really the one that we have to beat. I'm also thinking like in terms of like getting people to actually use HEIR to like write their applications. If we are, double-digit percentage points faster than OpenFHE, I think that's like the point where people, will be actually bothered to use it, right? Heck, they could just write an OpenFHE program and we sort of like, we trace it and we just run like we just raise it up to CPKF or something and lower it again. Like that would be bad, but like I think being faster than OpenFHE is like a nice goal for us, and it should make reviewer number 2 appreciate the novelty and impact and whatever.
Do we think it's very feasible that we can beat OpenFHE?
Why not? I mean, like HEIR and MLIR was I think noticeably faster than HEIR, right? And HEIR was a highly fine-tuned like implementation. So I think the biggest hurdle is probably like big algorithmic like things where like just our entities are worse or like our memory management is worse or something. But like beyond that, I think the effort to like fine-tune a C++ implementation is way higher than to like add a bunch of like highly targeted people optimizations for LLVM dialect. I think probably at the NTT level, it's probably going to be like more like about matching performance, because I don't think there's that much you can like optimize there. It's really when we look at like higher level ops, right, where we can actually do constant common substitution elimination and things like that.
With NTT wise, it's just basically much as Kanye Wasser's PhD thesis re-implementing for all of the 2 or 3 major architectures that we want, and that's it as well. So, well, I just think that research has already been done, so we can just port it and.
Okay, no. I think there's no academic interest in doing this, but I think it's like a necessity to make HEIR sort of like appeal to people that actually want to run.
But I mean, also like it's not. We don't need to reinvent the wheel and try to find what is the best possible entity in MLIR. Yeah. Let's get that.
No.
Is it?
I mean, at the very least, we should be able to beat the non-like AVX 512 version, like the vanilla OpenFHE. I think beating the Hexel version probably requires like, actually actually maybe not. Like I don't know how good LLVM is at like figuring out. This would be really interesting to see if we can maybe very easily enable like AVX 512 support or something. Because I know the Hexel like extension to OpenFHE was a lot of work. And if we can sort of demonstrate that we can get close to that performance with very minimal effort, that will be another like nice showcase of the power of MLIR.
Is it an ID to? Well, no.
I mean, it's probably like an LLO option, right? That or LLC option where you say like run super vectorizer or whatever, and then it vectorizes it.
Well, I guess my point is that like if it was that easy, then like writing a C++ program and like enabling that flag should also just be the task. But I guess like the Hexel support in OpenFHE is a bit more intense. But
well, is that just because they're embedding the assembly in line?
That might be one thing, right? Like so it might just be because they have to embed assembly. It might just be because they're doing like inter-procedural optimizations that we don't have to do because we can just emit like way larger functions, right?
Mm-hmm.
I think that will make for good research, like synthesis issue is actually like what exactly is like the magic that makes Hexel go fast?
I would guess it's like a AVX implementation of NTT, but
Right, yeah, I assume, but like, what's the what
Yeah.
makes it so much faster than like what I assume is also a very high quality NTT and like standard OpenFHE with like LLVM compile, right? I think exactly what you said. Like, what's the difference between what Hexel does versus just compiling a like well implemented C implementation with like SIMD vectorization? I'm sure the paper has words on this, right? Like that should be in the paper. Cool. Okay, so I think we found. Okay, sorry, Mark. We started with like scheme selection, and we found like this whole. This is how it always goes with this project, right? Like we start with like a simple goal, and then we realize there's like about a dozen other like fairly heavyweight infrastructure things we would like to do as part of this. Like if you had to pick like what do you want us to do first so that you can do actually interesting scheme selection things. Oh, I think you might be muted.
I mean, for the scheme selection stuff, I think I can start with using implementing timings myself and running the just kind of profiling by hand the different schemes. So if the schemes are lowering well comparisons and stuff, then this will be helpful. But so profiling inside HEIR, having it would be nice, but I think I can work without it. So and I can start that part without relying on that.
Awesome.
Yeah, this is giving me an itch, like the kind of itch where I like put aside the thing I need to do something fun. Even though it doesn't seem fun, it's like, oh, this is fun for me. I could I could do this.
MLA Stockholm syndrome.
Yeah, well, I've come to really appreciate the community. Now I'm like doing a lot more upstream maintenance of stuff. So I am the most active reviewer of dialect conversion changes now upstream. And that's because the person actually doing the work has no one to review his code, but they're doing basically changing dialect conversion to be one shot. So you like it basically simplifying it a lot and making it so that we can do like upstream all of our context aware stuff requires this dialect conversion stuff to be migrated. And yeah, I don't know. It's been nice. And I did this. I don't know if I ever really showed this off, but I have this little project. So I added an upstream feature that basically every time a pattern runs, it will mark like output to like a log file, basically what patterns or what ops were modified, what ops were removed, what ops were created. And then I use that to create like a search index so that you can say, okay, I want to know what are all the upstream patterns that replace whatever math.sign with something else. And then it will give you a page showing all of those things. And I have the green light to, okay, I don't have the example running here. But I have the green light to basically upstream this once I have the time to do it. But like, I feel like doing like core infrastructure work and like making MLAR nicer to work with. Like, I feel like there's a lot of warm reception to those kinds of ideas.
Yeah, talking about the community, I think for those that maybe don't follow like LLVM MLAR as closely, the registration for the developer meeting that's going to be happening at the end of October, as usual, in Santa Clara, is open now. Matthias, who's the guy who's doing the dialect conversion, will be talking about his one-shot dialect conversion, right? So I think there's there's always, of course, a bunch of LLVM related talks, but I think more than half of the content at this event tends to now be MLAR, just because that's sort of like, what's hot right now. And there's, of course, also like a one-day MLAR workshop that happens there. So maybe we'll hear about your Pathfind there, Jeremy?
I won't be able to attend.
But yeah, I'm planning to be there if nothing, unexpected happens.
I really should find a way to go there. Our travel budgets are right now. so
maybe
I
if you
probably
really
won't be
want
able to
to
get
go
work
on-
to pay for me to go.
Yeah.
Or even to pay for registration, unfortunately.
Yeah, it's unfortunately not a cheap event, but it's a very nice event.
Maybe I can call in. Alex, you can open your laptop when I'm there, and we can.
I can
have
like stick a
discussion.
GoPro or something to my
the two-headed hair developer.
hair draw.
Oh, I like it.
Cool.
Okay, all right. Let's end this nonsense. I will.
Some good work.
Yeah, I'll stop the recording.